The Emtec is a tactile sensation analyzer, an objective way to measure softness, roughness and stiffness of a textile fabric. With the device, we can measure the three basic parameters that determine human hand feeling: the softness, the roughness, and the stiffness. But also the elasticity, plasticity, and hysteresis are measured, and also these three have a certain influence to the overall haptic impression of a human. The device is a simulation of the human hand and the haptic sensors which are located in the skin and which are responsible for the feeling. The lamellar corpuscles, the tactile corpuscles, the Merkel cells, and the Ruffini bodies. But not only the single haptic parameters have an influence to the human feeling, also the temperature and humidity, personal preferences, market-specific preferences, sensitivity of each tester, and the daily mood of the tester. The TSA measurement is a two-step measurement. The first step is a sound analysis. The second step is a sound analysis again, followed by a deformation measurement. In the first step, the roughness is measured by a noise analysis. A plastic film and the sample are fixed together in the device. The plastic film is put underneath the sample, and the optimal size of the sample is 100 square centimeters as a round circle. The plastic film is placed in the middle. On top comes the sample. Now the fixing ring is closed. It is important that there are no wrinkles on the surface and that the sample surface is plain. The handles need to be locked. Now the measurement can be started by pressing start in the PC software. The measuring head moves down to the material, a load of 100 mm is applied, and the rotor with the 8 ceramic plates starts to move over the material. This gets the sample into vibration, which causes a noise, and the noise is recorded by a microphone which is located underneath the sample. The intensity of the noise gives us an idea of the roughness. The second step is the measurement of the softness, the stiffness, and further deformation parameters, again by a noise analysis and a deformation measurement. After the roughness measurement, the sample and the plastic film have to be removed from the device, and the same piece of material which has been tested for roughness has to be fixed again in the device, but without plastic film. The measurement again can be started with the PC software, and once started, the measuring head will move down to the material. Again, a load of 100 mm is applied to the sample. The rotor with the 8 ceramic plates starts to rotate, but this time we measure the sound that is caused by the vibration of the plates that are moving over the material. And after that, a deformation measurement is done where we apply a load of 100 to 600 mm on the sample and measure in-plane stiffness, elasticity, plasticity, and hysteresis. This has to be done 5 times, maximum 8 times. The average value has to be taken, and then you can compare this to other materials. Important, always only average curves have to be compared. There are currently 6 important parameters that are measured by the device. Micro surface variations, which represent the softness. Macro surface variations, which represent the roughness. In-plane stiffness. The elasticity, elongation and stretch. And the recovery. The independent ability of these 6 parameters opens a huge number of possibilities to use the TSA throughout the complete production chain. In the research and development, process optimization, incoming control and quality assurance, complaint management and troubleshooting, as well as benchmarking. And as an extra function, a hand feel value can be calculated, which as a single value correlates up to almost 100% with human expectation. Please visit our website and also LinkedIn for further information and interesting stories. Thank you for your attention and interest. Please feel free to contact us in case of further questions. We offer all kinds of different services and support around our products. Test measurements, on-site visits, support during trials, for example machine trials or trials with additives, and training, on-site or via web meeting.